Welcome back to Let's Clone. My name would be Stephen French, and this is part 2 of whatever the hell we're making here. I don't know, just kind of implementing random things into some random project and seeing where it goes. This time we're doing a mini-map to the procedurally generated dungeon that we made before. So we're going to kind of blow up the room size, throw a camera in there that follows a player, and then give ourselves the ability to render a mini-map up in the top left corner. I guess this corner, yeah, top left corner of the game. And yeah, that's pretty much it. So let's jump right into it. Okay, so first things first, we got to make our room bigger and throw a camera in so we have a map worth having a mini map for. If you can see all of it, there's no point. You just have access to your map. So I worked this out to be 1600 by 1600, and we're going to need the use of a view. Our view is going to be 320 by 320. And we're going to use a port of 640 by 640. And let me just make sure that we toggle visible and enable views. So what we're going to do is we're going to be seeing this 320 by 320 square, but we're actually going to blow it up to be 640 by 640 on the screen. So we're going to be a little bit more zoomed in on this game than we were before. Well, like twice as zoomed in. Where's my camera guy? Here we go. So then if I make this bigger, you can see a little more. There, so we set our viewport for viewport 0, right here, 320, 320, 640, 640, and then object following. It should say something about a camera, but it doesn't. We're going to set it to the object player. Set this to 320 by 320. Since the window is going to be 640 by 640, even though the game space isn't that many pixels wide, what we're viewing is, it should be counting that, I believe. It doesn't matter. If anything over half would be good. It's just going to force the camera to keep the player in center. By having a speed of -1, which is the default, the camera is going to be able to move as fast as the player, no matter how fast the player moves. Not end game type of, or I guess end result type of aesthetics, but it'll just follow the player for now in the way that we need just for it to work. But we're going to come down into our workspace, and all of our changes are going to take place, I believe, inside of our system object. So first things first is this is going to be a toggle. It's going to be a Boolean. So we're going to do it in here where we did the other one. So you want to have a variable that's either true or false, and then we're going to use the M key to toggle if that is one or the other. So we're going to display map, display mini, whatever you want. We're going to set this to true for now just for testing. Actually, if you go down here, you can set it to a Boolean as true. This means that when the game loads, it's already going to be displaying. Normally I wouldn't set it to that, but this just makes it easier for while we're testing and looking at the different generations. So later on, set it to false. Right now we're going to initialize it to be true. And we will actually need something in the step event, not in our debug functionality. We're just going to have a toggle minimap. We're going to say if keyboard check, I've got a 0 floating in there that we don't want. Keyboard check pressed. We actually want it to be pressed, unlike my mistake in the last part. ORD, don't know what it stands for, but I think of it as saying word, as if there was a W there. Oops. Oh, Howard. But this is just what you do to give it a character that you want to type on the keyboard, instead of having like one of the virtual keys that are assigned to it. And for some reason, it has to be in uppercase, so not W. ORDM, because I want to be able to hit the M for map and have the map display. And all we're going to do here is display map turn blue, so I know you exist. Okay, is equal to not display map. Exclamation point just means the antithesis of. So if this is false, we're going to set it to true. If it's true, we're going to set it to false just by the stroke of the M key. Now the draw event is fine. That's where we're drawing the world itself. We could draw the minimap here and have it like kind of locked to the corner of the camera, but there's no point. We're going to draw this as a GUI. So it is drawn in front of everything else. Draw graphic user interface. Sorry if those other words weren't quite readable. We're going to draw mini map, and we need to check to make sure that we are in the condition that we want to be. So we want to know if display map is set to true. If it is, we're going to do a bunch of stuff. If it's not, we're going to ignore all of it. So to start off, we're going to need a couple temporary variables for minimap size, and we're going to need one for minimap cell. It's cell size, or rather like right now a sprite is 32 by 32, but we want to render that as just like a couple pixels. So we're going to use this variable to denote that. We want the size of the minimap just for the size of our screen. I guess I could do this more dynamically, but I chose to have it 200 by 200 up in the top left corner, and I think it looks all right with the scale of the game. And then for the cell size, we actually need it to recognize the size of the room and scale it down to the same ratio. What I mean by that is we're going to take our size of 200 and we're going to divide it by our grid size. Grid size we've stored locally. This is what I would have had put as a macro, but we set it here because of this tutorial where we're going to be changing it around, so I wanted it to be a little bit more dynamic. Right now our grid size is still the room width divided by the cell size. Cell size is still 32 by 32, and our room width is 1600. So that gives us a grid size of 50 cells now instead of our previous 20, so a decent bit larger. And our path size is now, it's 50 times 50 is going to be our overall amount of space, when we're still going to just do the ratio of having half of that potential map be path, or be pathable. So we now have a ratio of 200 divided by 50. And what that does for us is it pretty much just gives us a 4, 200 divided by 50. And that's how wide each of our pixels is going to be. So we have 50 sprites, or I guess 50, they could be sprites, you could render them in there, but they're so tiny it doesn't matter. We're just going to use solid blocks of color. We have 50 cells that we're going to fill. So say that we had an absolute path of green going all the way across, so it's 50 wide. We have a 200 pixel wide map, so we need to render all of those to fill that 200 pixel wide space. We have 50 things. If we have 50 things at 4 pixels wide each, bam, you have filled your 200 wide space. And from here, we're going to start actually generating the terrain. So draw, minimap, I guess. Now, I don't want to have to draw every single thing. I don't want to have to check if there's a void or if there's a path and draw each one, because there's no point in drawing a whole bunch of tiny black spaces for the void. So you can choose this part or not. We'll probably try testing it with or without it, but I'm just going to draw a gray slate over everything and only put the path blocks on there. Anything that's gray is going to be the minimap's version of a void. So we're going to draw, set, color. I don't know why, but I like the one with a U in it, even though I'm in America. Dark gray. Oh, that line should not be there. So we're going to draw a color of dark gray. We're going to draw a rectangle of size 0, 0, minimap size, minimap size. So it's going to be from the top left corner 0, 0, and it's going to go out 200 pixels and down 200 pixels. And lastly, we need to tell if it's going to be an outline or not. I'm going to say 0 for false, or you could type in false, whichever you prefer. And this is going to draw just a gray slate of where a minimap will be, which is a good reference to test. Not really a reference, but there we go. See, if I hit M, it goes away and it comes back. So that's where our minimap will be rendered in just one tutorial length away. Now, just like when we set the path in the grid, we need to run a nested for loop. So it's actually for. So I'm going to do the same variables that I did before. II is equal to 0. II is less than, which one? I think we're going to do minimap size for this. Yeah. No. We need to do the grid size. Grid size, because it's going to be 50, so we need to check all 50 spaces. II++. Then the nested or interior for loop. I'm going to have variable jj is equal to 0, not car jj, variable. And then we're going to have jj is less than grid size, so we check all the way to the bottom of the grid. And then jj++. You should stop. There we go. Now we only want to draw this if our grid space is a path. jj is equal to path, which is our constant that we've saved in our macro. So if it is true that it is a path, then we're going to draw set color to be green, because that's just the color of the floor that I've made, just so it looks similar. And we actually need to draw the rectangle itself. Now, since we need to make sure we cover all the way across the board, we're going to do minimap cell, times II. I'm going to do the minimap cell times JJ. Let's do it correctly now. And we're going to have minimap cell times II. And then this part gets a little bit weird. It's plus minimap cell minus 1. Now this I actually don't quite understand why we have to. If you were to run this in HTML, you wouldn't do this. It's what I'm trying to do is we're setting the start of the next little cell to its correct position, and we're going to draw it 4 pixels wide. Since again 4 times 50 is filling our 200 pixel wide minimap. But when you actually draw it to be 4, they all overlap each other, and then the scale's a little bit weird. Drawing to 3 looks right, even though it shouldn't. But in HTML5, you wouldn't do the minus 1. That part kind of gets to me, but this one does work. So we're just going to go with it. So minimap cell times JJ, do the same thing here, plus minimap cell minus 1. And then we're also going to tell this that we don't want it to be outlined. And I think that is all that we have to do if we were to only render the map. So let's give that a test. We also want to draw our player, and additionally, if we want, we can draw an outline of, I guess, the border of the camera. So right here we have our minimap rendering the entire screen. The player is down in this little point, but if we hit escape, we're generating different minimaps. And you can hide the minimap with that. Now, like I said before, whoa, if we were to get rid of this line here, the draw rectangle, then you're only going to be drawing the map space, which does look decent. The only issue with that is, well, something that'll be apparent soon. So we have just that green here. Now, since it's a bit of a different green than we have for the grass, it's not terrible because you can still see it over the map, but if they were the same green, it would hide it. There's plenty of ways you can get around it. A simple one is just doing what I've done by drawing that gray box. But that's for you to decide if you want to keep it. But we're not done yet. We would also like to draw where the player is in the map. We'll do that quite simply with setting a color first. Oh, wow. Draw set color. We're going to make it just sea yellow just because that's what I have the player as already. Oh, I don't know. I'm just going to make that a function. Then draw set, no, draw rectangle. But we do need to know a little bit more before we draw the rectangle quite yet. So we're going to create a couple variables. We're going to make the variable for the player's x and for the player's y. We need to know the player's x relative to the minimap space or minimap dimensions. So we're going to do player x is equal to minimap cell times object player dot x divided by the cell size. And we're going to have to do the same for the y. Oops. So we've got the variables that we need. Now we can go in and start drawing the player. So for our x1, we're going to do player x. For our next one, we're going to do player y. Now for the width, we've got to do something that we just did up here, but now with the player. So player x plus the cell minus 1. Oops. And the player y plus minimap cell minus 1. And then also 0 because we don't want to draw, or we don't want it to be just an outline. And yeah, let's give that a play, see if our player is rendered in the correct location. If so, you should be able to kind of traverse the entire map without looking at the main screen, just looking at the minimap. And there we go, we got the player, he's moving around. You can see that he kind of snugly fits into the spots in the map. Again, if you weren't to do that, or to not do that -1, you would have a weird look to it. And we've got ourselves an entire little minimap. Everything is randomly generated. You can get some pretty neat looking worlds without having to do any work. Well, I guess you've already done the work, but yeah. So the last part that I want to do is actually the trickiest of the parts. I want to draw the frame around the camera. I want to put that in the minimap as well. It's a little bit silly. It's not needed to be done, but I kind of like how it looks when it's in there. So we're going to draw camera box. Sure. Now some of the math here gets a little bit tricky, so just try to follow along. I'll do my best to explain everything after. We're going to first set a color. And this time I'm just going to use the regular gray. Let's get a little more room. Just drawing that to be gray. We're going to need a variable for the view size. It's the size of the camera window itself. But we need to do some math here. So room width divided by camera get view view width. Then we need to tell it what camera we need, which is view camera 0. Now we need to adjust what the view size is a little bit. View size is equal to the size of the minimap divided by view size. So we can get a kind of scaled down version because we know that the camera is 640 pixels wide. We need to scale that down to an appropriate size for inside of the room. And because of how we want to draw it, we want to draw it from the middle point out. So we only want to know half of the size to the left and to the right. So we're going to say view size is times equals 0.5. You can make this all one line of code. I just think it's a little bit easier to read and understand when you're breaking it all apart. I probably could have also done a whole bunch of commenting, and that would have been for the better. Next up, we need a couple local variables to kind of get the x and y coordinates of the view itself, or I guess the camera. I should be calling these camera x, camera y, but I didn't. We're going to actually clamp these. Give them the clamps. And let's space these out the way I have been. So player x view size, since we've cut it in half, and size minus view size. Now why I'm clamping these is when the player moves all the way up to the corner, the camera can't follow him into looking at the nothing. The camera kind of stops and then the player leaves the center and goes up to the corner. So when we draw the frame of the minimap, I actually want it to clamp to those positions. So we're looking at wherever the player is. If the player gets lower than the width, or I guess lower than half of the width of the camera, then we're going to lock it in place. And you're going to see that in practice when we're actually moving around the map. But we do need to do the same thing for the Y. So player Y, I want to create a little bit of space here, or view Y rather. I'm going to take the player's Y position and we're going to do the same thing, just clamping it inside of the minimap where we want it to be. Now we can actually draw the rectangle in its correct position around the player. So it's going to be view x minus view size. It's going to be view y minus view size, which those view x and view y are relative to where the player is. It's going to be view, not q, it's not even a word, view x plus view size again being half of the dimension of the camera after being scaled down to the minimap dimensions, and then view y plus view size. Now this one we do want to be an outline, otherwise it's just going to cover up the player and cover up the tiles behind it. And what that does here is it gives us the size of the camera that is around the player, and it shrinks it down into the correct size to fit into our mini-map to make it kind of a relative scale. And then we're cutting that size in half, and we're drawing that rectangle at that half distance to the left, right, top, and bottom of the player, which creates that full, 2 halves equals a whole, creates that full size around the player. We're also clamping those positions, so if here's the top of the game room, and here is the top of the camera, this is terrible. You know what? I can do that over here. You know what? You're just going to see it in the game when we launch it. So you're going to press play. You're going to see that in the minimap, the view follows around the player, and when we get to the corner, you're going to see what the clamping has done. So we have this little guy moving around, and you can see the box here. What I like to do is kind of put myself into a position and observe how much of the space I'm able to see. So we know that it looks like there's a wall right below us if we go down 1 frame, and then there it is. Now if we go right 1 frame and down 1 frame, we'll see that the other one is. I popped down 2. But now if we go all the way down to the bottom of this particular dungeon, now when we get to here, if we were to go down 1 more, the player is going to start moving down because the view can't exceed the size of the game room. If we hadn't done this clamp, then this box would just follow the player down. But since we clamped it, you can see that the view stays still and it works for all dimensions. So I like that little touch. It's just a little bit extra, nothing that needs to be done, but we did it anyways. I hope this made sense. It's all a little bit convoluted, but if you do the math and write out the variables on paper, it's rather simple, just algebra. You just don't want to do everything with magic numbers, because now we can change the size of the camera, and for the most part, these should all kind of calculate themselves to still fit. And that's just about it. This is a very simple way to draw a mini map in the corner of the game screen. I used this back in my last game jam, which you can find a link to in the description. And I even had objects kind of roaming the map. And since I didn't have their position in the grid that we could use for the mini map, I did the same thing that I did with the player, and I took their position, I scaled it down appropriately, and just like rendering the player in the mini map, I rendered the monsters as well, so you could track them down in the mini map. It's really easy to do, pretty simple, pretty decent on saving resources, since you're not actually drawing more objects into that, you're just drawing little rectangle sprites. I like how this mini map system works. It's pretty expandable, and you can play with it however you want. If you come up with anything neat, just leave a comment to your project. I'd love to check it out. And like I said last time, if you have any mechanics that you want to see them cloned, you want to see them implemented into this, I'm going to be just searching around for weird little mechanics and throwing them in and just creating a little hodgepodge of mechanics for this project of tutorials. I don't know what it's going to turn into, but it could be something neat. We can make it together. Thank you so much for watching. My name would be Stephen French, and this has been Let's Clone.